Hello, good morning. So have you all joined offline or online? Hello? Yes, Kamlesh?
एनालिस्ट के लिए कौन सा सॉफ्टवेयर लगती है?
किसके लिए?
एनालिस्ट
एनालिस्ट के लिए। वो क्या एनालिस्ट?
डाटा एनालिस्ट
सर एसक्यूएल में इस एक्सेल और एसक्यूएल।
टैबलेट
टैब्लू अगर एक्सेल है तो टैब्लू नॉट रियली रिक्वायर्ड। अगर बहुत कॉम्प्लिकेटेड क्वेरीज करना है तो बट नॉर्मली पैरेलल में सब हो जाए। और बाकी लोग आएंगे या क्या? ये तो दोनों ऑनलाइन है।
हाँ मैंने ना दिखाया हाँ विचार मी काय नाही सर आहे चालेल कोमल मिळेल काय
नहीं आएंगे नहीं आ रहा। क्यों ऑफिस में?
Parking.
ये ऊप्स कॉन्सेप्ट समझ में आ गया?
क्या रहता है कोरिलेशन रहता है उसमें और
जी आज ऊप्स नहीं है ना, सॉरी. So today we'll start introduction to deep learning.
very good. Okay.
So deep learning is also, some people call this as advanced machine learning. Now, what is deep learning? How is this different from the standard techniques that we have followed? So that is what we are going to see. So today we'll, so this is going, today's session will be all the conceptual part, okay, just the theory part, because once that is done, hands-on becomes easy. So from tomorrow onwards, we'll do the hands-on exercises. Today we'll understand what are the different components of deep learning. How is it different from traditional machine learning, applications, usages, etc. Okay. Now, typical deep learning, so typical machine learning. What do we do in this? We do a prediction, which is known as the Y variable. Okay, and we have the data. So data can be in form of numeric or categorical. And this is a tabular format. Right? Then we build the equation y equals a plus bx in regression, and then for classification we build the log odds, etc., and then we do the prediction. Okay. Now, when we do a machine learning technique, there is always a risk of getting high errors, isn't it? Because we are finding out the values for A and B, and we apply this value of A and B to predict the value of Y. Okay, so we get something called as the error or the root mean square error, mean square error, all those things. Okay, so this is a typical ML cycle, machine learning. Now, in deep learning, we use the same technique of predicting the y variable. Okay, so we have a y, we have an x. The formula is also getting built, but in a slightly different way. So here we use something called as a stochastic gradient descent approach. ये नाम सुना है? Gradient descent.
सर लीनियर रिग्रेशन
Linear regression पे सुना है ना? So it uses the concept of gradient descent method. Okay, now I'll explain the concept later on, that what is gradient descent. So when we apply this gradient descent algorithm, we get optimum values for A and B. Okay, optimum value means the errors are reduced to a great extent. So you're not taking only the first value of A and B, you are optimizing it as much as possible so that the error is reduced. Okay, so this is done using a technique called as back propagation. So this is one unique feature that we use in a deep learning technique, back propagation, and this is done when you are converting your data into tensors. Tensors. हमने किया था ना TensorFlow last week. What are tensors? So your data gets converted into tensors. So this is one area where deep learning is used. The traditional machine learning algorithms like regression classification. Abhi ML mein we had different algorithms, isn't it? The names were different. We had K nearest neighbors. Then we had random forest decision tree. So here we don't have that. We have a classification, we have a regression. That's all. Okay, we don't have a separate name. Now, apart from the traditional machine learning algorithms, DL is also used for processing complicated algorithms or complicated solutions. Number one is image processing, or I could say image classification. Okay, now what do you mean by the term image classification? What are the areas where image classification can be used to solve problems?
Mobile unlock, face unlock.
Yes,
Yes, sir.
louder.
Mobile face unlock.
Okay, mobile face unlock.
कार में भी होता है.
So wherever you are dealing with images, okay. So how do you identify? One simple example. This is an image. Let's say this is a mobile. So how does the algorithm know this is a mobile?
Standard size.
Now human beings understand shape and size, right? How does a machine know shape and size? Correct. This is where the data gets converted to tensors. Okay, machine does not understand shape, size, color. All it understands is 0 and 1. Okay. So how does image classification work? How does the algorithm know that this is a mobile and not a sandwich or any other thing? Okay, so this is where we use deep learning to do image classification. And it can also be used in life sciences, agriculture, where let's say a farmer wants to find out whether his crop is a good crop or a bad crop. One common problem is infection of the crops due to termites, for example, or some uh, other causes. So he'll take a picture, and from that he can identify whether it is a good crop or a bad crop. Okay, doctors use it, whether the condition of the lung, whether condition of the heart, whether you have a problem or not. Okay, so these are image classifications, and the present day algorithms are so advanced that it gives a very high accuracy. Okay, almost 90+% accuracy can be achieved if done properly. So how do you do this? So you have techniques which we'll see now called as nodes, activation functions. Okay, nodes, AFS activation functions. Then you have layers. So all these things put together, we are going to build something called as a deep learning network. So network building is something that will come from the problem statement, how deep the network should be. Okay, I'll explain the meaning of why is it called deep learning. Okay, so how do you want to build a network? How many nodes you want, how many layers you want. So all these things comprises a complete deep learning network. Okay. Then the next area of application is video. Then you have audio. So you can do motion picture analysis, video analysis. You can do audio analysis. You can take a sample of a sound and try to identify whether it is genuine or fraud, male or female, whether it is belonging to a certain person. So all these things can be done. Now, what is one common thing when you're dealing with audio, video, and images? Hmm? Frequency of
voice, audio, video, voice.
Anything else? So this is on one side. Then I have regression. That is a typical machine learning, regression and classification. So this is on one side. So what difference do you see between these two models?
रिग्रेशन में हम प्रेडिक्शन करते हैं, क्लासिफिकेशन में हम
दोनों में प्रेडिक्शन है ना, रिग्रेशन में भी है, क्लासिफिकेशन में भी है. Think. Don't think the obvious.
Unformat way of data.
Okay, correct. That is one. So one is the format.
Unstructured.
Okay.
हमारे को प्रेजेंट यहाँ पे नहीं
हाँ वो फॉर्मेट में आ गए. ठीक है, ठीक है. Anything else? When you have a file, what is the first thing that you see in that file? और क्या क्या देखते हो उस फाइल का related to that file?
इनपुट एंड आउटपुट
फाइल का
File format.
सीएस
फॉर्मेट हो गया. Then
डाटा नॉर्मलाइजेशन
file size. Right? हम बोलते हैं ना, अरे फाइल साइज इतना बड़ा है, इट इज नॉट ओपनिंग. अभी ऑडियो वीडियो इमेजेस का व्हाट इज द फाइल साइज? It is very big, especially video files. Okay. Now, when you have a huge size of the files, उसका processing कैसा होगा? So, what is required so that you process things fast? So, you need a fast machine. Okay. So, this is machine dependent. I won't say dependent, it is I would say memory dependent or memory intensive. Okay, so when you are processing a 1 minute video and you have a 8 GB RAM, so how long do you think it will take?
1 minute video with 8 GB RAM.
And if you have an 8 GB RAM and you have a Excel file of the same size, okay, the processing will be faster on an Excel file. Okay. So it is memory intensive. So if you remember last week, I told you about CPU and GPU. Yeah, that TensorFlow comes in two flavors, CPU version and GPU version. So when you are installing a GPU version, you are basically going to work on these things. Okay, when you are working with regular text files, then CPU is sufficient. Okay, you can use GPUs if you can provide, if you have that facility, then you can use it. But when you are having a limited resource, then it is going to be very difficult for you to analyze video, audio, images. Okay, 10 files, limited files, fine. Or if you are having a compressed version, that is fine. But when you're dealing with high intensity or high resolution images, then it becomes difficult. Okay. So deep learning is used to perform the traditional ML techniques and also videos, audio processing, images. Then what are the frequently used applications if these are supported? Now you must have seen when we are searching for something, Google may have a lot of other applications, you can speak, isn't it? Let's say Australian Open. So it will translate that audio, or sorry, that verbal into a text. Right? You can try it on your machines if you have, I mean on your phones. If you speak something, it translates. Okay, so that is one area. So that is called the speech recognition. और कहाँ पे है speech recognition?
Image processing.
Speech recognition. Other examples.
Vitals.
कौन सा?
Vitals.
Vehicles में है, yes, all the new vehicles which come, no, you can say open driver side window, no, it will open.
And घर में भी लोग लगाते हैं.
घर पे है, Alexa है, then all those other, you know, so they have become a very common tool these days. A lot of people have it. So ये सब, how does it work? How does speech recognition, how do you think it works?
Audio system. We have
Sir, first we train it with some words and some way of speaking. Actually, train it with the wavelength of the sound and then it matches the sound, I think.
Correct. So if the speech has to work, it has to be trained first. Correct. So that means now let's say you are telling a word, okay, window. Now 100 people can say window in 100 different ways. Accent ke saath, a lot of window, and you know, there are too many things. So the training time required for the model to learn is very high. Okay, so first the model has to be trained and then it has to be applied. And whatever new things the model is learning, that also gets stored in the memory or into the model. So it is continuously learning. So that is another difference between machine learning and advanced machine learning. Machine learning में क्या है? एक बार learn किया, that's it. The formula is applied. But here it is not like that. It is continuously learning from the data. So that is why if it makes a mistake first time, next time that mistake is reduced. And third time it will never make it. Because it is learning from its previous one. Okay. So this is the biggest advantage using AI in certain areas. Of course, some areas it is also prone to bad things, frauds and all. But if you look at the good things, a lot of these things are really handy for a lot of people. Okay, so speech recognition is one. Have you heard of self-driving cars?
Yes.
कैसे काम करता है? Speech से.
Image or videos.
Image and distance. Like this is like time चल रही है, सामने कोई object आएगा, वो with the binary जाने को, so you have to tell them कि if something comes with this type of code, like 0 1, then it's an object we have to store.
Okay. So what is the source of your data?
Video.
It could be video or it could be image. Again, if there is a car going, so either the motion can be captured and it can be processed, or the photo can be taken by the sensor in the vehicle and it can be processed. And then it can do something called as an image classification. अभी एक object है ना, whether that object is a person or a stone or a vehicle or a lamppost, how do you know? So that is a multi-class classification of an image. So within that fraction of a second, the system has to come up with the solution or the prediction that this is what it is. So imagine the amount of training the model has to go through. Isn't it? How do you know that this is a human being? Human beings come in different shapes, size, color, dress hai, आधा है, पूरा है, so many things, isn't it? So the amount of training that is required to train the model is huge. So imagine the data, imagine the size. Okay. So this is an example of self-driving cars using deep learning techniques. और क्या है? Text processing.
Capture it.
नहीं, capture I won't call it as a DL method. It can be used क्योंकि it's an image. But text processing means when you are processing huge amount of written text. Okay, for example, I have let's say a novel, first chapter of a novel. So how many pages will be there? Let's say 15 pages. Okay, each page has around 200 and 300 words. So total words कितने हुए? 300 multiplied by 15, whatever it is, 45, 5,000, 6,000 words. Now, how do you get a summary of the first chapter? मुझे first chapter का summarize करना है in 50 words. How do you do it? Okay, so this is where text processing is used, which is called as NLP, natural language processing. Okay, so this also uses the deep learning techniques where text is taken as my input, which is the whatever language it is, English, any language. And from that language or from that text, the important words are taken. The words which do not give a meaning are discarded. And then you count the frequency, you count what is the significance of the word, you count what is the importance of the word, you count what is the occurrence of the word in the overall document, and then say that this word is significant. Which sentence is significant? Putting all these things, you make a précis. Okay. So this is non using text processing, and for this you definitely need to have a GPU system. Another commonly used application is language translation. Language translation, you all know what it is. English to Hindi, Hindi to Marathi, Marathi to Hindi, English to French. So how does that translation happens? How does it happen? So data is fed, model is trained, and one question can be asked in different ways, right? So how does the system know that this is what I have to answer? Question can be in different way. Okay, so this is another area called language translation. Then you also have games. Chess khela hoga online. Okay, that is also now it is very difficult to beat a computer chess player because millions of moves are stored in that and processing is within a second. And then any new thing which the computer sees, it learns that. So imagine the power you can generate. So there are lots of games. Online में जितने भी games है, it's very difficult to beat them. Especially when you're playing with a machine. Okay? So these are things that is fed to the system and it also learns from the system. Chatbot का नाम सुना?
Yes, sir.
Now these days every service industry has this, right? You never speak to any person. You book a ticket, next minute आपके WhatsApp पे you will get a message. This is the ticket, and if you want to have anything with respect to the journey, there's a number given. You activate that, and you get the automated system. So you press 1, let's say reservation. So you get a set of questions based on reservation. Then within that, you have sub-menu. Okay, so this is an automated chat. So you're actually chatting to a machine. So only when the machine is not able to answer, it goes to some person. Okay, otherwise everything happens by these applications using deep learning. These are deep learning, all these things. So it's what is common? The data, the training of the data. Okay, the model is built using these data and high accuracy. Okay. Any questions?
Model build वाला model build thing है deep learning में and all. So these all are going to be static, right? For all.
Machine learning is static. I mean, that is what we're going to discuss now. So now we will see the common, some of the differences between ML and DL. Can we say deep learning is machine learning? Yes, both are machine learning. No? Machine learning has this approach, DL has this approach. But end of the day, both are machine learning. Okay. So traditional, I'll write traditional machine learning. And here I will write deep learning. What is the first difference?
Continuous one. No,
So in a in a traditional machine learning, features are provided. Correct? You have a data set, you have the features. So features are provided. Deep learning में features are learned. अभी वीडियो फाइल है, ओके, उस पे फीचर्स क्या है? We cannot provide a feature list, isn't it? If I'm taking your photo and I want to analyze this, now what feature will you provide? Features are learned. So next, the training time. So in a traditional machine learning, the training time is usually less. मॉडल कितना टाइम लगता है बिल्ड करने में? 1 से 2 मिनट. Unless you have a big file, or you have a big file and a system which doesn't support so much of, then it takes time. But otherwise, generally, training time is less. Deep learning, training time is a lot more. Third difference with respect to data. If I'm implementing, let's say, a classification model or a regression model, and I have only 200 records, I can build my model, correct?
Yes.
And it will give a reasonably good output. But if I am doing a deep learning and I want to do a language translation, how much data is required? Can I take 200 people's sample and try to do a translation? It is not going to be possible. Okay, accuracy will be very less. So here data, I can do with less data, but for a deep learning, data has to be huge.
But so the data has to be like auto updated, right? Because it can be changed and everything. Because in machine learning, that particular set of data is fixed, like 200 or 300, like we take a sample. And based on this, we are going to actually predict on the collection of how the data is going to be. But in DL, it has to be completely updated. Because the data cannot be fixed and change.
Data cannot be updated. Data has to be learned. The features have to be learned from the new data. Okay, for example, let's say that I want to predict whether this image, let's say this is a house. Okay. Now I can flip this image. This is also a house. Again, this is also a house, but the image is in a different way. This is also a house. Now, if I show this image to a human being, can he identify this also as an image, as a house?
No.
क्यों नहीं? अगर एक बच्चे को बोलो ये घर है, and if you tilt that image, can you identify it's a house?
Yes, sir.
Okay, but machines won't do it. Because for a machine, a 1 degree tilt is a new data. You remove 1 pixel and put a white color, that is a new data. Okay. So every small thing, whatever change that you make is a new data to the machine. So that is why learning as much as possible will give you a better result by using a deep learning. That is why training time is more. Data is more. Okay, you cannot generalize. Okay, generalization is possible, but again, it has to first learn before you can generalize. Clear? So in terms of data, traditional machine learning can be done using less data. Deep learning requires a huge collection of data. Fourth one, with respect to machines. Traditional machine learning I can use with a relatively small configuration. I would say small to medium configuration. Whereas deep learning requires a high to very high configuration. Now imagine that you are dealing with an image. Okay, it's a very small image. Let's say it's a 32 by 32 image, 32 pixels width by height. Okay, and it's a black and white image or a monochrome image, chota sa image. Now, how do you want to, when you double click an image, how do you see that image? Do you see the entire image or do you see pixel, 1 pixel at a time? एक साथ दिखता है ना? It doesn't okay, pehla pixel, then doesn't happen that way. Even background pe, that is what happens, but when you see it, it is one whole thing. Okay, now this is what happens when you are working on a very high configuration. And when you have a high resolution image, you want to see the entire data getting processed all at once. Okay, so this can only be possible when you do parallel processing. अगर serial करेंगे तो क्या होगा? 1, 2, 3, 4, 5. Okay. So that's why the configuration makes a big impact on the deep learning learning. And the last one is in terms of interpretation. So in a traditional machine learning, you get an output which is easy to interpret. So, whereas deep learning is a black box. Black box माने क्या है? You feed input, you get an output. So you do not know what is happening. Okay, जैसे support vector machine है. Okay, so deep learning is a complete black box. So you do not get output. I mean, you do not get a value that you can interpret. So it is not easy to interpret. यहाँ तक समझ में आ रहा है? Any questions online?
No, sir.
सर एक चीज पूछनी थी,
हाँ,
तो जब डीप लर्निंग में भी वो लाइक और दिस लाइक इंटरप्रिटेशन वाले बात पे, अगर डीप लर्निंग में विल बी हैविंग समथिंग फॉर ब्लैक बॉक्स, राइट? यहाँ पे हम भेजेंगे बट वी वोंट बी अंडरस्टैंड, वी वोंट बी नोइंग व्हाट इज हैपनिंग इनसाइड एंड इट विल गिव अस अ रिजल्ट. So that black box thing will be a standard process, right? मतलब it is going to be pre-built.
what is pre-built? The
Pre-built means like for that particular part, particular algorithms or those things will be already predefined,
no.
which we are going to use.
No, it's not like that. In fact, we are going to start that chapter for how it works. See, when you are building a machine learning, you have a data set. Then you have the algorithm here. And then you get the output. Okay. Now you cannot change anything here. What is the maximum that you can do here? You can do the hyperparameter tuning. Okay. Where this is machine learning. In deep learning, the input is the same, output is the same, but the processing, what you do is in form of something called network. Okay. So the network is going to determine how efficient your output is going to be. अभी हम लोग करेंगे what is the meaning of network? That is known as the ANN model or artificial neural network. So this is what you have to design. So the definition of the network, the designing of the network will determine the final output. Okay, so this is the difference between machine learning and the deep learning architecture. Okay, next topic is ANN, that is artificial neural network. कोई बायोलॉजी स्टूडेंट्स है यहाँ पे? बायो स्टूडेंट, बायो पढ़ा था ना स्कूल पे एक दो
Yes,
साल,
sir. Yes.
तो थोड़ा तो याद रहेगा बायो. This is, I would say, class 8, 9, 9, 10. Okay, who's that time? Now in bio, you would have probably heard these terms, neurons. नाम सुना? न्यूरॉन के अंदर न्यूक्लियस रहता है. ओके, नाउ ये न्यूरॉन क्या है? डेंड्राइट,
Sir,
डेंड्रॉन.
it is a cell connecting like from brain
Yes,
to
louder.
from nerve connecting from brain to other parts of the body.
Correct. Okay. इसका what is the use of these neurons? Transfer of
data.
information. ठीक है? Transfer of information from one neuron to other neuron till it reaches the destination. और कितना टाइम लगता है? Microseconds या उससे भी कम. Isn't it? Instant. यहाँ पे गर्म पानी है, you keep your hand within what, a fraction of a second you take out your hand. तो वो information कहाँ से आ रही है? From the brain. Okay, so brain is continuously scanning for information and it is sending to every part of the body. ठीक है? But the information is significant only when there is a certain action. अभी यहाँ पे भी information है, but is that significant? Okay. So continuously the brain is sending information through neurons. So this is the idea behind deep learning, that you create something called as neurons. So neurons कैसा होता है? Something like this. Okay. And then these are this is neuron, this is, ma'am, I'm very poor at drawing. So these are known as the dendrites. So यहाँ से information goes and then it reaches the next neuron and it goes on and then you get the final destination. So this is where the action will happen. What is to be done? Okay, so this is the input. The next neuron will process this information. So this is the information that is sent. So neuron 1 will send information to neuron 2. Neuron 2 will process the input. It will do its own processing. And then it will send the processed information to the next. This neuron 3 will process the information from neuron 2. And then it will do its own processing and then send it to the final one. So ये chain दिख रहा है? So this chain, when we implement in deep learning, in machine learning, in deep learning, we build the network. And because we are building all these different neurons, so you have a neuron here, a set of neurons here, we have a set of neurons here. So because we can build as much as we want within this network, and because it is deep down, that is why it is known as deep learning. Okay, so this is my first layer. I can call this is my second layer, this is third layer, and this is my nth layer. Okay, this is my input, this is the output. Input क्या है? Features. Output क्या है? Prediction. Okay, so I have the input features with me. Output is known to me. Okay. Now I want to build a network which is going to get the good predictions, and that is done by constructing something called as the network. So the components within that network is known as layer. So these are all layers, which is called a hidden layer. That is, you cannot see those hidden layers. And you can stack these layers horizontally, you can stack it. So that is what is called deep layer.
There is no limit, no limitation.
Your system configuration पे depend है.
So आपने accuracy उसमें हमको नहीं लगेगा सर.
हाँ, वो you have to do the cross validation. So it is an infinite combination of opportunities. Okay, so this is the fundamental concept of deep learning. Why is it called deep? Because you are stacking these layers. And within each layer, you have multiple components that we'll see now, nodes and activation functions.
That was great like that.
Abhi, heavy or a subject? It's actually a very heavy topic.
Interesting है but थोड़ा wait.
We'll take a break. 10, 20, 15 minutes.
Okay, sir.
Okay, we'll start in some time.
मेरा टेस्टिंग से इतना हमारा में एक्चुअली कोई टेस्टिंग नहीं है मैं पर्टिकुलरली जो टेस्टिंग की नहीं जो सिर्फ टेस्टिंग नहीं करती हमारे में लाइक मिक्स टीम है हम कोई मतलब टेस्टिंग नहीं कर रहे जैसे कल जो इशू है तो बिजनेस में नहीं किया बट बिजनेस में हम नहीं होगा फिर डिस्ट्रीब्यूशन देते हैं नेक्स्ट टाइम के बताने में थोड़ा टाइम लग गया और में वो 2-3 लगेगा टाइम ट्यूसडे नहीं लगेगा एक दिन में कुछ फर्क है
Okay, let's continue.
मीटिंग है ना प्रिपरेशन चल रहा है
Okay, so let's understand the meaning of ANN, artificial neural network. So this takes the idea from the brain. There's a brain. We have the neurons, so it uses the same technique. Okay, so how it actually works. So we have something called as layers in artificial neural network. Okay, now there are three main types of layers. One is called as the input layer. Okay. Then the second one this is where we build the network. This is called as the hidden layer. So we can say we build our network here. And then we have the output layer. So in the output layer, it can either be the Y variable, which is a regression, or the Y variable could be a classifier. Okay, so classification can be binary or multiclass. Okay, this is the overall overview of the artificial neural networks. Now, what is this input layer? This is a tensor. What is the hidden layer? This is also a tensor. What is output layer? This is also a tensor. Okay, now the input layer is the feature or the list of features. And the output layer is the output label.
So B or M.
Kaha?
B or M.
Binary and multiclass. ये समझ में आ गया basic architecture of a network. So there are three layers: input layer, hidden layer, and output layer. Input layers, output layers, and hidden layers are all tensors. We have already seen what are tensors. They are arrays, okay, which can be 1D, 2D, or ND. Input layers are the input features. Output layer is the output label, which is either a number or a classifier. And the hidden layer is the tensor, which contains the creation of the network. Okay, now let us see the details of what are these tensors made up of. So I'm just going to put the input layer here. So input layer is nothing but the individual features. Okay. So I'm going to represent this as circle. So each individual point is called as a node. Okay. So let us say this is age. So age is a node. Let us say this is a salary. So salary is a node. Okay. So node kya hai? It can either represent your data or it can represent a calculated data. Okay. So यहाँ पे, since this is a first layer, this is your actual data. So when information goes from here through the hidden layer, the nodes inside the hidden layers get information from the previous layer. I explained that, है ना? ठीक है, imagine there are 5 doors, 1, 2, 3, 4, 5. So first person entering from 1 will give something to 2. Second person waiting at door 2 will take that, do something, check, give it to the third person. Third person will see, acha, this is what it is. Okay, my input goes to the fourth. Okay, so sequentially the data passes. समझ में आया?
सर जो तुमने बोला था जो पैरेलल ग्रिड होता है वो क्या है?
Parallel?
पैरेलल ग्रिड जो आपने जो डिस्प्ले नंबर इमेज है ना जो पैरेलल ग्रिड होते हैं बोला था अभी बोल रहे तो सीरीज में होता है
वो GPU का बोल रहा था. That is not layers. That is different.
Multiple comments.
ठीक है, तो लेयर क्या है? सीक्वेंशियल प्रोसेसिंग होता है. पहले डेटा गोज टू द सेकेंड लेयर. ठीक है, तो पहला जो लेयर है that contains your actual information, so that node will contain data. अब वहां से डेटा सेकेंड लेयर पे आ रहा है, तो वहां का जो नोड है इट विल कंटेन द प्रोसेस इंफॉर्मेशन. जब थर्ड पे जाएगा इट विल कंटेन प्रोसेस इंफॉर्मेशन ऑफ द सेकेंड लेयर. फोर्थ के पास जब आएगा इट विल कंटेन प्रोसेस इंफॉर्मेशन ऑफ द थर्ड लेयर. फोर्थ के बाद इट विल मेक अ डिसीजन क्या करना है. दैट बिकम्स द आउटपुट लेयर. ठीक है, सो दिस इज अ नोड, दिस इज अ नोड. So you can have as many nodes as you want depending upon how many features you have. So let's say I have 3 features. So age, salary, and experience. Okay. Okay. So there are 3 nodes. So this is my input layer. Okay. Now this age contains the actual data 25, 40, 39 in form of a tensor. Okay. Now because of the huge amount of calculations, the first thing that we have to do is make the data into a standard form so that it contains only 0 and 1. That is between 0 and 1. So ये जो information है, this is in the standard format, or I should say standardization, not standard format. Sorry, this is standardization. That is between 0 to 1. ठीक है, same thing for salary, same thing for experience. Okay. Now we all know the formula for linear regression, which is what? Y equals A plus bx. है कि नहीं? mx plus c, a plus bx, सब एक ही बात है. Here we have something similar. We have the same thing, a plus bx, but it is written as wx plus c. Same है. Instead of the b term, we call this w. W here represents weight. और जो a है यहाँ पे, that is called c. C represents the constant term. Okay, exact same thing.
Sir, standardization means that we apply min max scalar or the transformation, right?
Yeah, correct. But preferably 0 between 0 to 1.
Okay, sir. Yes, sir. Got it.
Okay, now how does it actually work? Abhi, my data is there, which is X. X is the data. Okay. Now, in the first layer, I'm going to generate random weights. So I'll create how many weights? W1. Because there are 3 features, I will create random weights W2 and W3. पहले iteration पे I'll be creating W's. हमारा objective क्या है? We have to get the formula. Why I'm talking of a regression. Just to make things simple. In the regression model, what am I going? W equals W1 x1 plus W2 x2 plus W3 x3 plus C. This is with respect to this data that I have. Okay, 3 features. Now, how do I get the optimum value for W and C? वही हमको करना है, right? Can we change the value for x1?
Yes. Yes.
x1 क्या है?
Yes.
Age है. Can we change the value?
Why?
Salary instead of, we can take salary instead of age.
नहीं, changing the value. अगर किसी का age 25 है, उसको मैं 65 कर सकता हूँ. No, I cannot tamper the value of the data. है कि नहीं? तो x1 I cannot change. x2 I cannot change. x3 I cannot change. Correct? तो क्या change कर सकता हूँ?
Wait.
Only the weights and the constant term.
The weight to the ratio होगा. Weight ratio होगा ना.
I'll explain क्या है. This is where we use the gradient distribution. Okay, so initially I'll be generating random values for weights W1, W2, W3. Okay, so it can be something like this. W1 1.138 randomly generate कर रहा हूँ. W2 equals minus 0.337. W3 equals 0.559. ठीक है? Random generation. And then select a random weight for C, which let's say 2.234, for example. Okay. Now I'll be doing the calculation. W1 x1 plus W2 x2 plus W3 x3. Okay. So W1 x1 plus W2 x2 plus W3 x3 plus C. Okay. Now the information that I get from this is what? Is the Y value. Correct? अब ये जो information है, this goes into the hidden layer. So this is my hidden layer. Right? So I'll just rub this part and I'll include okay, so now this is my hidden layer. Now, in this hidden layer, I can have any number of nodes. यहाँ पे कितने nodes हैं? 3 हैं. Now, in the hidden layer, I can have any number of nodes. I can have 1 node. I can have 2 nodes. I can have 3 nodes. I can have 4 nodes. I can have 5 nodes. Okay, that is up to you. So this is usually done using cross validation. Okay, so let's say we have only 1 node, just to make things simple. Okay, so 1 node है यहाँ पे. Now, what is the function of a node? मैंने क्या बोला था?
Process जो input है process.
Node is for processing the information, right? अब ये जो node है, ये क्या है?
ये input है.
Input है, so there is nothing to process. ठीक है? तो ये जो node है, it will apply the formula W1 multiplied by X1. ठीक है? So W1 X1 plus W2 X2 plus W3 X3 plus C. ठीक है? So it will sum up all these numbers. So ये क्या return करेगा? This will return a single value, right? So this will return a y. समझ में आ रहा है? Now this information goes to this node of the hidden layer. तो ये hidden layer का पहला layer है. I told you you can have different layers. Hidden layer is a big, मान लो it's a rectangle. उस पे you are drawing vertical lines. So each rectangle forms a layer. So here I have 1 layer. Okay, so like this you can have many layers. This is 1 layer, this is 1 layer, this is 1 layer, and each layer can have nodes. ठीक है? So that is why this is called deep. ये देखो कितना depth है इसमें. There are 4 layers. So right now we have only a single layer which has a single node. Okay. Now when the information from the input layer comes to the node of the hidden layer 1, this forms the prediction. Correct? This is the predicted value. Okay?
Yes.
Now, is this value right or not right?
Partially.
It's a prediction.
This is a prediction. Okay?
Yes.
For every record, let's say यहाँ पे I'm getting, I have 100 records. I'm getting 100 values in y hat. Right? तो ये prediction right है या wrong है? How do I know?
Cross validation.
So I have to use y minus y hat. Actual value minus predicted value. जो हम करते थे in linear regression, that is called residual. है कि नहीं? Residual means actual value minus predicted value. Now it will do the same thing. अभी prediction हर एक का हो गया. Now it will check whether this is 0 or how far from 0. ठीक है? अगर मान लो एरर बहुत ज्यादा है, because we have taken random values here, so chances of error is on the higher side. है कि नहीं? Now what is going to happen? This is going to send the information back to the input layer. Remember I told you in the morning session back propagation.
Yes.
So ये है back propagation. Now back propagation क्या करता है? Because the error is high, now I want to minimize error. तो क्या कर सकता हूं यहाँ पे? I cannot change x1. I cannot change x2. I cannot change x3. Right? So what can I change? W1, W2, W3 and C. Okay. Now, will I again generate a random number? No. तो यहाँ पे मैं क्या करूंगा? I am going to do a partial differentiation. Partial differentiation with respect to the error. ये थोड़ा सा mathematics है. I won't get too much into the detail, but you have to know the term. Partial differentiation with respect to error. Partial differentiation का मतलब क्या है? D of W1 with respect to the error term. Okay. D of W2 with respect to the error term. D of W3 with respect to the error term. And finally, D of constant with respect to the error term. So you will get 4 different values. समझ में आ रही है?
Yes.
So data comes from the input layer with randomly assigned weights. हाँ? Constant भी है ना? So randomly assigned weights multiplied by the data, that will be the first round of prediction. Second step, error is checked, which is this one. Then error is high because I want to optimize the values. I cannot change the data. Go back to the first layer or the previous layer. Then what do? You find the partial derivatives with respect to error. हम स्कूल पे हमने इंटीग्रेशन डेरिवेशन किया था, याद है? dy by dx. So here it is not d, it is this d, partial. Okay, now this partial derivative will return a value. Okay, so I'm going to call this as derivative of 1. This is going to be derivative of 2. This is derivative of 3. And this is derivative of constant. Okay.
Yes.
Now what is going to be the new weight? Now W1 is now going to be W1 minus D1. ठीक है, अगर नेगेटिव है तो वो पॉजिटिव बनेगा, पॉजिटिव है तो वो कम होगा, कम है तो ज्यादा होगा, ज्यादा है तो कम होगा.
Cross validation तो करेंगे.
वो बाद में करेंगे, after you build the network. So the new weight is going to be the old weight minus the derivative. W2 का क्या है? W2 minus D2. W3 क्या है? W3 minus D3. And constant क्या है? Old constant minus derivative of the constant. समझ में आ रहा है? अभी यहां पे क्या होगा? दिस एग्जाम्पल, दिस इज ओल्ड वेट, राइट? अभी नया वेट क्या होगा? W1 is going to be 1.138 पॉजिटिव नंबर है, तो इससे थोड़ा कम होगा. So let's assume this number is 1.115. W2 क्या है? It's a negative number, so that means it will increase. So let's say this becomes minus 0.285. W3 0.559, so let's say this becomes 0.519, and C will be 2.167.
Basically जो हमारा डेरिवेटिव आएगा, that we are going to subtract from the
Old value,
original base.
old value minus derivative equals new weight.
तो ये जितनी बार बैक एंड फ्लो करेगा उतनी बार वो रिड्यूस होता रहेगा,
Because you are optimizing the coefficients.
हाँ वेट और कोएफिशिएंट.
This is coefficient. So this is back propagation.
बट जैसे हमारे पास तीन पैरामीटर हैं, एज, सैलरी एंड एक्सपीरियंस.
Correct.
तो वो तीनों को हमने
W1, W2, W3 है ना, इसीलिए derivatives with respect to the error.
पूरी उसी कैंटिटी को W1 दिया हुआ है.
See, अगर तुम, if you want to understand the mathematics,
नहीं, समझ गया.
what is the equation for y bar? Y hat क्या है?
Minus
It is W1 x1 plus W2 x2 plus W3 x3 plus C. ठीक है? What is error? Y minus y hat. है कि नहीं? Now y minus y hat को हम कैसा लिख सकते हैं? Y minus y hat can be written as y minus W1 x1 plus W2 x2 plus W3 x3 plus C. Correct? What is this term? This is error. Now what are we doing? ये जो term है, we are finding the partial derivation, that is dE by dW1, dE by dW2, dE by dW3 and dE by dC. तो partial derivation का मतलब क्या है? If we are doing with respect to W1, ये सब जीरो हो जाएंगे. अगर W2 है तो W1 will become 0, this will become 0, correct? W3 है तो W1, W2 and C will be 0. जब C है तो W1, W2, W3 will be 0. ठीक है? This is actually y minus y bar the whole square. So यहाँ पे एक स्क्वायर भी है because it is sum of squared errors, ना? ये क्लियर है? मैं डेरिवेशन आई वोंट गो इनटू मच डिटेल, वो बाद में टुमारो आई विल प्रोबेबली कवर दैट, बट अंडरस्टैंड द वैल्यू दैट इज कमिंग हियर. तो ये क्या आएगा? दिस इज डेरिवेटिव 1, दिस इज derivative 2. This is derivative 3 and this is derivative of constant. Derivative का मतलब क्या है? Rate of change है कि नहीं? Now W1, that is a new weight, equals the old weight minus the rate of change, which is V1. So if W1 is positive in the previous iteration, the new weight will be less. If the weight is negative, the weight has to increase. So it will become more than the previous one. I won't say positive, gradually go positive. And gradually it will be less. Is this clear? The idea, is this clear? So now again, this is called back propagation. Now second iteration, new weights, but the data is the same. So फिर से यहाँ पे आएगा to the layer. Again this will happen. Again this will go back. So this whole process of back and forth is called a back propagation. So it will do it for some k times. Okay, default is around some 500 or something, which you can hyper tune. 1000 chahiye, kitna chahiye. So let's say this is happening for 500 times. So that is the reason why deep learning takes a lot of time to get compiled, and why it is high in accuracy, because it is optimizing at each level. अगर मान लो मैं सिर्फ ये लेता, the errors would have been very high. So gradient, so this is done using the gradient descent algorithm. So this back propagation is known as the gradient descent. The errors are high, go back, optimize, come again, check. High, go back, come again. Clear है?
Yes.
Now assume that this operation is done 100 times. Let me just rub this part. Okay. Okay, so now I have the y variable here. Now the data has to be between 0 and 1, correct? Data has to be between 0 and 1. अभी यहाँ का जो डेटा है, is it between 0 and 1? No. अभी इसको 0 and 1 के इंटरवल पे करना है. Okay, so now we have in this layer, in this node, every node has something called as activation function. Every node has an activation function. अगर दो node है, so this node will have its activation function. This node will have its activation function. ठीक है? अभी activation function करता क्या है? It will convert this input into a range between 0 and 1. That is the functionality of the activation function.
Irrespective, it's going to be negative or positive.
तो हम पहले जो आपने इनपुट लिया था,
हाँ।
अभी स्टैंडर्डाइजेशन किया था,
हाँ।
0 to 1 पहले ही रहेगा वो।
हाँ,
वो जो नोड की वैल्यू होगी 0 to 1, फिर हम क्यों अभी एक्टिवेशन यूज कर रहे हैं?
weights अलग है ना?
ओके, वेट सिमिलर रहेगा तो नहीं करेंगे हम।
Value of prediction,
क्या?
value of prediction, y है.
Yes.
So y की value होगी.
हाँ, हाँ.
Value of prediction will be between 0 to 1, always 0 to 1.
नहीं, value of prediction नहीं है. This is the converting the value into a range 0 to 1. ठीक है? ये क्लियर है?
डाटा हम नहीं स्टैंडर्डाइज करके देंगे लीनियर में
Activation function वाला part clear है?
Yes.
Okay. Now this is a hidden layer which has one layer and one node. ठीक है? एक node, this is a node, and this is a single activation function, and this is one layer. ठीक है? तो input layer हो गया, hidden layer हो गया. What is the next one? Output layer. अभी आउटपुट लेयर का इंफॉर्मेशन कहां से आ रहा है? From not activation function, from the result of the activation function. Okay, so from here. So what is the formula? W1 x1 plus W2 x2 summation plus C. Okay, same thing again will happen. Random generation of weights, and then you will get the predictions. ठीक है? So this whole architecture is called as a single layer perceptron. So single layer perceptron means when you have n inputs, you have a single hidden layer and a single output layer. Single input layer, one hidden layer, and one output layer. Online, any questions from anyone?
No, sir.
I नहीं किया. Okay. ये clear है?
Yes.
Now, this is a most basic network that you can build. Now we'll see what is the meaning of multi-layer perceptron. So let's take a same example. We have three features. So I'll have the input layer. So let us say that I have three features. Okay, this is feature 1. This is feature 2, and this is feature 3. Okay. Now I'm going to create my hidden layer. Now in the hidden layer, now I'm going to have one layer but two nodes. Layer एक है but multiple nodes. So here I am going to put node 1 in the hidden layer, node 2 in the hidden layer. अभी hidden layer 1 पे कितने फीचर्स हैं?
सिंगल लेयर रिसेप्शन में तो हमें एक सैलरी एक्सपीरियंस
एक मिनट।
फीचर्स लिए थे
हाँ
एक सैलरी एंड एक्सपीरियंस 3 फीचर्स लिए थे
हाँ।
these all 3 were individual nodes node 1 node 2 node 3
हाँ
ठीक है तो ये तीनों के कॉम्बिनेशन को हम एक नोड बोलते हैं राइट हिडन लेयर
नहीं कॉम्बिनेशन नहीं है वो. हाँ, you can say it is a it is actually the sum, it is a prediction that you get from that. It is not a combination. Combination का अलग meaning है.
तीनों का जो प्रिडिक्शन है,
जो prediction है,
one node,
that is a node. हाँ, correct.
input layer में वो तीन individual nodes होंगे. Their prediction is going to be a common node in hidden layer.
Which can be one or more than one node. Okay, so now let us see what is multi-layer perceptron. There are different variation in this. पहला variation है, input layer has 3 features. Every feature will have weights. Okay, now how does it work? अभी ये जो hidden layer है, let's call this as layer 1. Now layer 1 has how many features? How much?
3 feature and 2 node.
Hidden layer 1, L1 has how many features?
2.
2 features. इस पे कितने features हैं? 3 features. Now what did I tell you? When information goes from left to right, every node will contain is considered to be a feature, which will either have the information or get processed information from the previous node. है कि नहीं? तो N1 में क्या है? Processed information. N2 में क्या है? Processed information. And they are considered to be 2 different features, which are much different from node 1, which contains X1, X2, X3. Is this clear? Input feature में क्या है? Actual data. X1, X2, X3. Okay, it could be age, salary, experience. When data is processed, using मैं एक different color ink. So double. Now see, the information is going from input layer to N1. Similarly, a new set of information will go from input layer to N2. है कि नहीं? क्योंकि 2 नोड है.
node data
नहीं, W value change होगी.
W value will change.
like when node 1 is processing, it will have the original value. When node weight की original value होगी, जब node 2 is processing, तब node का minus करके जो value है वो.
नहीं. Node 1 जो है, it will get a set of W's. ठीक है? तो यहाँ पे it will get a set of W's and C. So let us call this as W node 1 and C node 1. ठीक है? ये W's कहां से आ रहे हैं? बैक प्रोपगेशन करके from input layer. Now I have one more node. तो उसका डेटा कहां से आ रहा है? from the same input. But इसका value क्या होगा? So let me put it in a different color. Let's take green color. X1 is coming here. X2 is coming here. X3 is coming here with its weight. अभी ये क्या होगा? Weight of node 2, C of node 2. Clear? Now you see the hidden layer. Layer 1 में क्या है? 2 node है. These 2 nodes are the features. Feature 1 is the red one. Feature 2 is the green one.
Yeah.
Understood?
WPL है ना, change हो गई इसकी। ये similar product में ऐसे बन सकते हैं ना इसमें।
अगर दोनों सेम है तो देयर इज नो यूज ना, तो इसके लिए एक ही यूज करो, सिंगल नोड. So you are enhancing the flexibility so that you get a better result. This is multi-layer perceptron. अभी इस पे अभी ये बन गया W1 for C1 बन गया, W2 for N2 बन गया, node 1 and node 2. Next, activation function. Very good. Okay, so here I will have, I'll just put a, so here activation function for the first node, activation function for the second node. अभी जो एक्टिवेशन फंक्शन है, देयर आर डिफरेंट फंक्शंस. ठीक है, सिग्मॉइड का नाम सुना है? सिग्मॉइड. सो सिग्मॉइड इज एन एक्टिवेशन फंक्शन व्हिच ट्रांसफॉर्म्स डेटा फ्रॉम 0 to 1, बिटवीन 0 and 1. ठीक है, अब मान लो यहां पे मैं सिग्मॉइड यूज कर रहा हूं, आई कैन ऑल्सो यूज अ सिग्मॉइड हियर. एक्टिवेशन फंक्शंस कैन बी सेम, बट इट विल बी अप्लाइड टू इट्स करस्पॉन्डिंग नोड. ठीक है, तो इट्स अ 1-to-1 रिलेशन. इस लेयर पे ये नोड है, इस नोड का ये एक्टिवेशन फंक्शन है. ओके, इस लेयर का ये नोड है, इस नोड का ये एक्टिवेशन फंक्शन. बट द एक्टिवेशन फंक्शंस कैन बी सेम, बट इट विल बी अप्लाइड टू इट्स मैप्ड नोड. अब ये सिग्मॉइड फंक्शन है तो इट विल बी अप्लाइड हियर. ये सिग्मॉइड फंक्शन इट विल बी अप्लाइड हियर. ठीक है, and now what do you get? Now you get the output. अभी आउटपुट कैसा आएगा?
Result activation 1 or 2.
Now this is the first data. है कि नहीं?
Yes.
So this is W1 of the layer 1 from the node 1 plus
See.
its bias. Correct? उसके साथ क्या कंबाइन होगा?
No.
W1 of the green plus of the layer 1 of node 2 plus C2. ठीक है, तो ये दोनों मिलके we will do the addition. ठीक है। अभी इमेजिन ये नहीं है। So now this will behave like your input feature 1 feature 2 है कि नहीं? वही हुआ ना? अभी ये नहीं है तो ये क्या हुआ? This is the input feature. This is feature 1 feature 2. उसका so W1 X1 plus W2 X2 and plus the constant. He actually C will be for not C1 C2, it will be single C.
If that
Layer का C है, okay? हाँ.
तो 2 बार C आएगा नोड 1
यहाँ पे C plus this will be plus C. जल्दी में गलत लिखते हैं क्योंकि the constant is only for the layer. Now you will get the predictions. Okay, this is multi-layer perceptron. So this is another way of designing your network. अभी यहाँ पे मान लो एक और नोड है. Then how will the information flow? X1, X2, X3 all coming to N3. Then you will have N1, N2, N3, W for N3 and then one constant. तो यहाँ पे 3 होंगे. So how many nodes you want? That will depend upon how simple or complex your data is. ठीक है, तो ये एक layer with multiple nodes. Now the other variation is multiple hidden layers with multiple nodes. उसका डायग्राम भी सिमिलर है. So this is the input layer. So let's say I have 3 features X1, X2 and X3. This is my hidden layer. So I'm going to have 2 hidden layers. This is layer 1. This is layer 2. Every layer will have its activation function. Now let us say I'm going to have 2 nodes. So in the first layer, I'll have node 1 and node 2. Node 1 will have its activation function. ठीक है. Now layer 2, I can have either a single node or I can have multiple nodes.
The same is possible in layer one also.
हाँ.
Randomly कुछ भी हो सकता है.
और ये मान लो मुझे if I have to have two nodes, so layer 2 will have node number 3 and node number 4, and this corresponding node 3 will have activation function 3, activation function 4. क्लियर है ये? अभी इंफॉर्मेशन फ्लो कैसा होगा देखो. x1 to n1 plus x2 w2 x2 plus w3 x3. फिर x1 to node 2 plus its weight, फिर this, और यहाँ पे there will be a C1. Constant एक ही है. अभी इंफॉर्मेशन इज कमिंग टू लेयर 1. अभी यहां से इंफॉर्मेशन कहां पे जाएगा? एक्टिवेशन फंक्शन में जाएगा. सो लेट्स अज्यूम एक्टिवेशन फंक्शन हो गया है. नाउ व्हाट विल हैपन?
एक्टिवेशन फंक्शन से n3.
सो हियर डेटा विल गो टू n3 and n4. है कि नहीं? And then second वाला data will go to this and this. फिर activation function, and then output. This is going to be from the node 3, from the node 4, यहाँ पे C2, यहाँ पे constant, and then this is
तो इसका सम जब हमारा आउटपुट पे जाएगा तो चारों का सम करके जाएगा. सम प्लस सी.
चारों का सम नहीं, लास्ट वाला.
एक्टिवेशन फंक्शन का हम AF1 AF2 कैलकुलेट नहीं लेंगे.
AF1 AF2 कैलकुलेशन के बाद फीचर बन जाएगा ना लेयर 1 का. सी जब यहाँ पे N1 N2 क्या है, वो अभी फीचर बन गया है. फीचर फॉर द नेक्स्ट लेयर. इनपुट लेयर में क्या है? x1 x2 x3. इट इज द फीचर फॉर द इनपुट लेयर. N1 and N2 is the feature for layer 1. ठीक है. So because of these complicated calculations, it is always better to transform the data between 0 and 1 so that calculations are much faster. ठीक है. So couple of questions यहाँ पे क्या क्या आ सकता है? Number of hidden layers कितना होना चाहिए? Can I say I want 5 layers or 3 layers? Okay, so you always start with one and then you configure the number of layers. So this is done by cross validation. So cross validation plus how your data is configured. So everything will depend upon the performance of the first model, data, and the results from the previous model. Number 2 is choice of nodes. So in दोनों को actually you have the same answer. How many nodes you want depends upon the data and cross validation. Number 3, the choice of activation function.
Same difference.
Activation function, you cannot use any function.
It depends on number of nodes.
No, it depends upon what problem you are solving.
Optimization.
अगर classification है, it's a different thing. Classification में अगर multi-class है, you will use something called as softmax.
But अभी आपने बताया ना कि every node is going to have one activation.
It will have one activation function. But what is that activation function that you have to decide?
Which one to use as a node or?
Every activation function, sorry, every node will have an activation function.
Compartment का क्या बताया आपने?
Activation function will depend on the problem. If you are doing linear regression, the activation function used is called ReLU, rectified linear unit, ReLU.
F is dependent. Activation function dependent on.
Activation function depends upon the problem statement. So there is a function called as ReLU, rectified linear unit,
Can you write it?
rectified. I'll explain the different activation functions. Rectified,
Really?
linear unit. This is the most commonly used. Okay, so whenever you have a regression problem, you will always use ReLU. For classification, for binary classification, I will generally use sigmoid. When the classes are linearly separable. When it is not linearly separable, I will use tan H, hyperbolic tan. There are many functions, so I'll try with all these different combinations. When you have a multi-class classification, I will use softmax. You have to use softmax. Softmax activation function. For multi-class classification problems. Is this clear?
Sir, it is clear, but the implementation will be this complex.
It won't be complex. You have to start with a single layer perceptron and then build the network.
Like in ML, we had a set of pattern like data cleaning, then it will also have a like pattern.
Those things are common.
Okay, sir.
The EDA will be done separately. Okay, this is the ML part. I mean, the DL part. जो आपने ऐसा EDA किया था. Okay, this is nothing related to EDA.
Okay. Yes, sir.
Data analysis, जो आप what you normally do, you will do. Once everything is done, then you will come to this part. Okay, this is the TensorFlow part. तो ये सब regular Python पे नहीं चलेगा ये code. You have to use the TensorFlow environment. Okay, so that is why in TensorFlow, if you remember, we installed TensorFlow and NumPy and Pandas so that EDA can be done there also.
Yes, sir.
You don't have to switch environments. Okay, ये वाला, is this clear? What is a layer? What is a node? What are weights? What is a bias? What are the three layers? What is a hidden layer?
Bias,
The C term.
constant.
Term is also known as bias. Wx plus B or Mx plus C. So C constant बोलते हैं. Here we call Wx plus B as the bias. ठीक है, just a few more points. What are the different types of layers? अभी है ना, time है. नहीं, just ये some basic calculations. Maths.
Very broad process करने के बाद तो not like that.
In fact, we can have some Q&A.
Flow wise something I am.
First तो समझ में आया, second में
अभी ये जो लेयर हमने बनाया था नेटवर्क, now this has a name. This is called as fully connected layer. Okay. So whenever you are doing any ML related models using deep learning, the network is called as fully connected layer. When you are doing image processing, you will be using something called as convolutional layer. तो हर एक implementation का अलग अलग नाम है. Okay, so when we do the image processing, I'll explain what are its specific layers. So there are some 5 layers for image processing, which after the image is processed will get converted into this, a fully connected. So convolutional plus fully connected. पहले ये समझ लो, this itself will take some time. What is an activation function? Activation function will give some meaning to the node by converting it between 0 and 1. Okay? Because we cannot use the value as it is, because it will be greater than 1. So to make it compressed, so you have to use the activation function. So activation functions give meaning to the nodes. What should be the action for that particular node? Break चाहिए 15 minutes.
Theoretically, this समझ में आ गया कि like what activation function we use, what are the layers, what are the nodes, process करने के बाद output कैसे वो होगा. Like the diagram वो चीज समझ में आ गई.
जब हम कल करेंगे, then you will understand.
हाँ मतलब picture थोड़ा clear ऐसे का clear नहीं हुआ तो उसका use कैसे होगा.
It is easy. I'll just list out some frequently used activation functions. So one activation function is called sigmoid is one. It's called identity. So here y equals x. That is a formula for this activation function. Then we have a sigmoid function. Y equals 1 upon 1 plus e raised to minus x. This is the formula. Then there is a binary step. So here the formula is y equals 0 when x is less than 0, y equals 1 when x is greater than equals 0. So another commonly used, so ये जो common ones है वो ये है sigmoid. Then this one which is called tan h. Tan h is hyperbolic tan. So इसका formula है y equals 1 plus e raised to minus 2x divided by 1 plus e raised to 2x. You don't have to remember these formulas. ये सब ऐसे ही. Sorry. One second. What is the 1 plus? अरे नहीं. 1 minus e raised to upon 1 minus e raised to minus 2x upon 1 plus e raised to x. Very commonly used function. Then we have ReLU, which is a very generic function that we use. So here it is y equals 0 when x is less than 0, and y equals x when x is greater than equals 0. And then we have softmax. Softmax is e to the power x divided by sigma of e to the power x multiplied by आप लोगों ने ये वाला किया है क्या इन did you cover boosting in your
No, sir.
previous class?
No, sir.
Boosting.
No, sir.
No. Boosting is an ensemble technique. नहीं किया ना? ठीक है, I'll explain softmax का simple फंडा ये है कि it is used in multi-class. Okay. The idea of softmax is the sum total of all the predictions should equal 100%. Okay, so मान लो there are 5 classes. This is class 1. This is class 2. This is class 3. This is class 4. And this is class 4 and this is class 4. Okay. Now there is a record. This can belong to 1, 2, 3, 4 or 5, anyone. So ये क्या करेगा? Softmax, it will calculate the probability that it is in class 1. So this will return, let's say 0.3. What is the probability that it belongs to class 2? Let's say it is 0.4. Probability that this is in class 3, 0.1. Okay, so this is 0.4, 5, 6, 7, 8 बाकी बचा. So this is और 0.2 बचा है ना. So so this is 0.08 and this is 0.12. ठीक है. Now find out which is the maximum. So इसका sum total कितना है? 1. So this record will belong to any one of the classes which is determined by the maximum number. तो क्या है वो? So record belongs to class. This is softmax.
Find out where the value is present.
This will classify a record into a class which has the maximum probability. This is actually ये concept deep learning में है, which is now taken in boosting method. Bootstrap नहीं, boosting. Bagging and boosting है ना दो method. Random forest is a what method? It's a bagging method. So वैसे there is something called boosting. So boosting uses this method. One of the methods. And even logistic regression में you can do multi-class by using softmax. ठीक है? Then what else did we cover? What is a node? What is the functionality of a node? How do you create the nodes, etc., etc.? All these things we covered.
Activation function.
Weights and biases हमने cover किया, activation function cover किया. So TensorFlow we have already covered. एक से I'm just checking कुछ रह तो नहीं गया.
क्लास करोगे इससे क्या तो आपने क्लास कर सकते
ठीक है, I think हाँ इतना ही था आज के लिए. There is a website, playground. Deep learning के लिए there is a playground website where you can design your network. Okay. Just do this search. Let me यहाँ पे मैं देखता हूँ. See, playground.tensorflow.org. This link. ठीक है, you can actually see this. यहाँ पे क्या है? एक learning rate है. Active learning rate मैंने actually this is part of the gradient descent algorithm which I'll explain tomorrow. अभी है, you want to do it now? नहीं करना. ठीक है, ठीक है, तो ठीक है, I'll explain this tomorrow then. ये epoch का मतलब क्या है? See that at least go through these terms. अभी यहाँ पे देखो. So there is a text called epoch. Then there is a term called learning rate. फिर यहाँ पे you will see activation. So this is the activation function. Then there is something called regularization. This fine, which is not really required as of now. What is the problem type? Classification or regression? Okay. This is the data. This is the feature, that is the input layer, the hidden layers, and output layer. What I explained in the morning. So you can configure all these things. अभी यहाँ पे let me just show you. ठीक है, अभी कुछ नहीं है. Input layer, output layer. ठीक है. How many features are there? Two features, X1 and X2. ठीक है. Now I want to add the layers. अभी मैं ये plus में click करता हूँ. So there is one layer having two nodes. Nodes is also known as neurons. एक ही बात है. Node, neuron, same thing. So this is what we did initially. One hidden layer having one node. One input, one output layer. ठीक है, हमारे पास 3 फीचर्स थे. So इसको क्लिक कर लो इस फीचर. So now I have 3 features. ठीक है. So input feature, one hidden layer with one node and output. ठीक है. What is the problem statement? Classification. If I select this as regression, the output will change. What is the activation function? ReLU, rectified linear unit. Now, if I press this button, it will build the model. ठीक है, मैं इसको क्लिक करता हूं. Now see, it is building the model. ये 153 जो दिख रहा है यहाँ पे, that is the number of iterations. Back propagation जो मैंने बोला था, how many times? So 153 number of times this model has done the iteration, and this is the output.
So in this we don't get code.
ये just demo के लिए, to understand the network architecture. हम ऐसा नहीं करेंगे, we will be actually writing the code. This is for your understanding. कि layer क्या है? Okay. Now if I have to add one more node, अभी देखो क्या होता है. Now see how the data is moving. So x1 से पहला नोड का, पहला लेयर का पहला नोड. So from here it is going here. From x1 x2 it is going here. W1 x1 plus W2 x2. ठीक है, इस नोड पे. अगला वाला कहां से जाएगा देखो. x1 will come here, x2 will come here, and then this will combine and give you this element. This is how the network is built. So this is a single layer perception. This is a single layer perception. This is a multi-layer perception. If I add one more hidden layer, so input data will come to this layer. There are 2 nodes. Each node will act as a feature. Then information from this layer will come to the second layer, and then the output. ठीक है, multi-layer perception. Visually ऐसा दिखता है. समझ में आ रहा है? What we study exactly यही है. Now what goes behind this? That is the calculation of weights and biases using stochastic gradient descent. वो मैं I'll explain that briefly. What is gradient descent algorithm? ठीक है, so ठीक है, आज we'll end it here. थोड़ा नहीं, ये वाला सब्जेक्ट ऐसा है कि यो थियरी अगर क्लियर नहीं,
थ्योरी के बिना काम नहीं होता.
थियरी अगर मैं कल शुरू करूंगा और से LR equals 0.002 क्या समझोगे?
कुछ नहीं।
Okay, Yash, कल we'll meet tomorrow.
Okay, sir. Okay, sir. Hello.